Alright, for this lesson we're going to be learning about discrete and continuous domains. If you have not gotten your textbook out or your math journals, pause this video and do that. You need to turn to page 156 in your textbook, and you need to have written the key idea and the vocab words and their definitions in your journals. If you haven't done that, please pause this video and do that now. If you have done that, make sure you also have a piece of paper ready to do the on your own examples as we go through this lecture. All right, so let's read about what a discrete domain is. It's a funny word, discrete. A discrete domain is a set of input values that consists of only certain numbers in an interval. So, for instance, a discrete domain includes the numbers 1, 2, 3, 4, and 5, specific to those numbers. A continuous domain is a set of input values that consists of all numbers in that interval. So in this case, it would be all numbers from 1 to 5. So for instance, 1.5 would be one of the numbers in this domain, or 2.5, or 3 3/4. These are all part of a continuous domain. How I like to remember it is a discrete domain has to be whole numbers. You can't have a part or a portion of whatever you're discussing. Continuous domain, you can have a portion of it. For instance, if let me see if I can think of a good example. If I'm purchasing books, a book, I can't buy a portion of a book. I have to buy the entire book. So that would be a discrete domain. A continuous domain would be, what if you're reading a book? I could read a portion of the book, even though I can't. I mean, I could read all of the book, but you could read a half of the book or 3/4 of the book. That would be a continuous domain. If you can break it into portions, then that's continuous. So let's go through this and do an example. So in your journals, here is example 1. Make sure you write that down. All right, so we have a chart on the left here showing museum tickets. And we have the function y equals 15.95x represents y, the cost in dollars of x number of tickets for a museum. Graph this function using a domain of 0, 1, 2, 3, and 4. Okay, domain is referring to which one? Input or output? Domain is input, so input is your x values. Okay, so these are all the x values. If your input is specific whole numbers, and you can't buy part of a ticket in this case, this is considered a discrete domain. Okay, so what they'd like you to do is graph the function using the domain that you I just read and decide whether the domain of the graph is discrete or continuous. Well, we already decided it was discrete. And the way to graph this is to plot ordered pair. So you're going to use this function. You're going to plug in each of these input values where x is. And the easy way to do it is make a chart. If this chart's big enough, we'll see. So when the x value is worth that amount, the y value is worth this amount. So our x values are 0, 1, 2, 3, and 4. Okay, Okay, so for each time we do this, we're going to plug in 0 where that x is. So you have 15.95 times 0, so y equals 0. Well, that's an easy point. If I plug in a 1, I get 15.95. If I plug in a 2, so that'd be 15.95 times 2, which would be 31.9. If I plug it in for 3, I get 47.86. Sorry, 85. That's a 7. And if I plug in 4, I get 63.8. Now remember, in ordered pairs, to take your x and y value. So for instance, this would be 0, 0. This point would be 1, 15.95. Hard to write small there. This would be 2, 31.9, and so on. So these are your ordered pairs that you graph, and you can see here how they're graphed. Okay, I'm not going to require you to graph these right now because I know a lot of you don't have graph paper. So for this particular example, I went ahead and put the graph up here so you can see it. So you cannot buy a portion of a ticket. So this is to reinforce the fact that this domain would be considered discrete. Okay, this looks like it's portions, you know, because they're decimals, but remember that is going to be the approximate, oh no, that's your cost. Okay, so that's in dollars, $15.95, $31.90. So that's money. So technically that can be a discrete because to 2 decimals, which should be a penny, you know. Anyhow. All right, so let's look on your own number 1. Put this on your piece of paper. The function m equals 50 minus 5d represents the amount of money, m, in dollars, you have after buying d number of DVDs. Graph the function, and is the domain discrete or continuous? So for here, again, you're going to want to make a table. Okay, now they use different numbers other than x and y. So how do you decide which of these is your x value and which one's your y value? Well, in this case, m stands for money, the dollar amount, whereas d stands for how many DVDs there are. So DVDs is kind of the more solid answer, where you know how money can be a decimal. So D would be your x value because it's a solid answer, and M is going to be your y value. So when you graph this, you're going to go across this way, 0, 1, 2, 3, 4, 5. And this way you're going to go up the dollar amounts. So 10, 20, 30, however you want to put that in dollar amounts. So we need to make a table to decide our points. So this is x, which is actually D, and then this is M. And then you can just pick how many DVDs you have purchased. So if we bought 0 DVDs, what would be our out? If we buy 1, 2, 3, 4, and let's just say we buy 5, up to 5 DVDs. We'll go from there. So we're going to plug this in. If I buy 0 DVDs, I'm going to plug in 0 here, which, by the way, this D value, X value, this would be considered my domain, right? So the domain would be 0, 1, 2, man, can you tell I'm doing this lecture late at night? 3, 4, 5. Okay, so plugged in 0, so 5 times 0 is 0, so this would be, I still have $50 because I haven't spent any money on the DVDs. I started out with 50 bucks. Okay, what if I bought 1 DVD? 5 times 1 is 5. 50 minus 5 would be 45, so I have $45 left. 2, 5 times 2 is 10. 50 minus 10 would be 40. put a 3 in there, I get 15. 50 minus 15 would be 35. You see a pattern. Okay, each time I buy a DVD, my amount goes down by $5. Surprise, surprise. Okay, so then you're going to want to graph these points. So remember that this point is 0, 50. So I'm going to say this is 1, 2, 3, 4, 5. Goodness, this marker or this pen doesn't like me. So this was 30, this was 40, this was 50. So my very first point is going to be at $0. 0 DVDs, I have $50. After I've bought 1 CD, I have $45. 2 CDs, I have $40. 3 CDs, I have $35. 4 CDs, I have $30. And 5 CDs, I have $25. When you guys graph these, I'm not going to be super particular. You guys know I can't draw a straight line to save my life. So I don't expect you to, unless you're using a ruler. And then the last thing it asks is whether this domain is discrete or continuous. What do you think? What are we dealing with here? Can I buy a part of a DVD, like the physical actual DVD? No. So if you can't break it into a part, this is a discrete domain. Now, if you were buying this off of iTunes or Spotify or all those ones, you could buy a portion of the DVD and buy one song. That would be continuous. But in this case, we're buying the actual physical DVD. Oh, I was thinking CDs for music. DVD's a movie. You can't buy part of a movie. You can buy the whole thing. Otherwise, how are you going to know the end? Okay, example 2. Put this in your journals. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Graph the function. Is the domain of the graph discrete or continuous? So the number of C calories consumed is a function of the number of bars eaten. All right, so calories consumed, C, is a function of the bars consumed. So let's say B for bars. How much is each bar worth? It's worth 130 calories. So here would be your function. My consumed calories is 130 calories per bar. Okay, so we're going to make a table first, and then we'll graph this. It's a tall table for some reason. Guess I was feeling entertained. All right, so X would be my bars, and Y is going to be my calories consumed. So if that helps you, put a B here and a C here. If I don't eat anything, I'm not going to have any calories. So that's an easy point. If I eat 1 bar, if I ate 2 bars, if I ate 3 bars, if I ate 4 bars, that's good enough. Okay, so if I plug in 1, where the B is, 130 times 1 would be 130. So if I ate 1 bar, I got 130 calories. If I ate 2 bars, I have 2 times 130, which gives me 260 calories. If I ate 3 bars, 3 times 130 would be 390. And if I ate 4 bars, 4 times 130 would be 520 calories. Okay, so this is eating granola bars or breakfast bars. I don't know what they are. Cereal bars. Yeah, breakfast bars. So this is how you would calculate the number of calories you have eaten. Now to graph this, okay, we're going to start at 0 and going across here. This is the number of bars, 1, 2, 3, 4, 5. And going up is our number of calories. Let's just say 100 Woo, that 0 came out funky. 200, 300, 400. You should be putting this in your journal. 500. Okay, so for the first one, if I ate 0 bars, I had 0 calories, so I'm going to start at 0, 0. So at 1 bar was about 130 calories, so it's right in there somewhere. 2 is 260. 3 is 390. 4 is 520. So there's 4 bars. It should be a straight line. I can't draw to save my life, but in general, this should be a straight line going up. Okay, now here is the last question. Is this a continuous or discrete domain? Now you notice our input values were whole numbers. However, what are we talking about here? We're talking about cereal bars, right? Can you eat a part of a cereal bar? Sure. If I'm kind of hungry or eat only half of it, I can definitely eat only half of a cereal bar. So you could have an input value here of 1.5, which give you a calorie value between these two numbers. So this would be considered a continuous domain, because you can have part of the input value. You can use a part of it instead of a whole number. I hope that kind of clears things up. Good. All right, make sure that's in your journal. Let us do example 3. All right, example 3. You conduct an experiment on the speed of sound waves in dry air at 86 degrees Fahrenheit. You record your data in a table. Let me take a picture of this table. Woo! All right, so here's our data table for the speed of sound waves in dry air at 86 degrees Fahrenheit. Which of the following is true? Oh, I guess I'll take another picture of this. All right, so here's our question. Which of the following of these 4 answers is true? Well, let's discuss these. The domain is t is greater than or equal to 2, and t is greater than or less than or equal to 10. Okay, first one, which is our domain? Domain would be our x value, and output is our range, right? So this is domain, this is range. So our input value, is it between 2 and 10? Yes, it is. Is it discrete? No, it can't be discrete because we're discussing air. Well, seconds. You can have a portion of a second, right? You could have 2.2 seconds. Okay, so it can't be discrete. Okay, let's look at C here. I know I'm going out of order. The domain is D equals yada, yada, yada. Is that true? No, domain. This is not domain. This would be the range for those values. So it can't be C. Okay, what about D? The domain is, again, the domain can't be that stuff. That's the range. So then our last one, haha, shocker. I know I surprised you here. The domain is T is greater than or equal to and less than or equal to 10. That is accurate. It's everything in between that, so that means it is continuous. So the correct answer is B. Okay, now this is something you guys haven't really seen. You see how normally when we have the domain, we've listed them. So it'd be like 2, 4, 6, 8, 10 is the domain. The domain can also be written in this way. It's domain is equal to 2. Wait, I'm writing this wrong. So you can have, in this case, it's T. So t is greater than or equal to 2 and less than or equal to 10. So this is also a way you could write domain. It kind of looks like a, what is this called? Man, my brain is tired at this time of night. It's on a number line. Can't think of the word. Inequality. Haha, it's an inequality equation. But this is another way you can look at domain, especially when it's considered a continuous domain, because it's everything from 2 all the way to 10, everything including in between there, which is what makes it a continuous domain. I hope I didn't confuse the heck out of you just there. All right, so let's do on your own. 2, put this on your paper. You're actually done with your journals if you want to push that aside for a moment. A 20-gallon bathtub. 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. Okay, when you hear draining, are we adding water or subtracting water? We're subtracting, so this is a negative 2.5 gallons per minute. The number G of gallons remaining, so that's the outside number, is a function of the number of minutes. So we're losing 2.5 gallons per minute. Graph the function. Is the domain discrete or continuous? Okay, so the first thing we're going to want to do is create a table. So here's my table. Ooh, it's a little crooked. All right, so we have our minutes and our gallons. At 0 minutes, how many gallons do I have? Right at the beginning of this, it told me how many gallons of water do I have in here. I have 20 gallons. Okay, so I'm starting out with 20. I think I need to put a 20 there. Yeah, I forgot. I needed to put in here. Oh, no, I can't erase it now. Okay, so this formula is not quite right because I started out with 20 gallons, so that needs to be in my formula. So rewrite your formula. G equals, we started with 20, we're subtracting 2.5 every minute. So I knew I was missing something. And that tells me how many gallons I have left after that. This G looks weird. So the gallons left is 20 minus 2.5 per minute. Okay, so then at 1 minute, I'm going to have 20 minus 2.5, which would give you, what is that, 17.5 gallons left? 2 minutes, 17.5. So I have 20 minus, so you'd put a 2.5 times 2. And subtract that from 20 gallons, so then you're going to have 15 here. After 3 minutes, you're losing another 2.5 gallons. So you put 2.5 times 3 and subtract that from 20, and I get 12.5. And after 4 minutes, I lost another 2.5 gallons. So I have 10. After 5 minutes, I lost another 2.5 gallons. So if I plug a 5 in here where the M is, 2.5 times 5, and then subtract that from 20, and I get 7.5, and that's enough input values for now. So then you would graph this. I'm going to have to move to the next page. I wonder if I can make a copy of this. All right, let me delete that one. Very cool. All right. I'm learning how to do new things on this sometimes. Copy. See if I can paste it over here. Oh man, learned something new. All right, so I brought my table over here. All right, so let's graph this. Move my table over so you can see it better. All right, so our gallons is going up here, and we started with 20 gallons. So I'm just gonna say, should I go by 2? That's too small. I go by 5, 10, 15, 20. That's kind of big, but you'll get the idea. 1, 2, 3, 4, 5 minutes. Okay, so then to graph these, my first point, 0:20, so I started out with 20 gallons. After 1 minute, I'm down to 17.5 gallons. After 2 minutes, I'm down to 15 gallons. 3 minutes, I'm down to 12.5 gallons. 4 minutes, I'm down to 10 gallons. 5 minutes, I'm down to 7.5 gallons. And so on and so forth. You're losing water out of this tub. It should be a nice straight line. All right, now the last thing to answer is whether this is discrete or continuous. Well, we're discussing minutes. Can I have a portion of a minute? Absolutely. So this would be a continuous domain. Yay. All right, last one on your own, number 3. Put this on your papers. All right, here's your question. Are the data shown in the table discrete or continuous? So we're answering whether this is discrete or continuous, and then tell me why. So we're the number of stories, 1, 2, 3, 4, 5, and the height of a building. So this isn't like book stories. This is stories in a building. So like if I have a Empire State Building, each level is a story. Okay, and there's 5 stories of this building. Can you have a portion of the story, like in a building? I mean, maybe when you're doing construction, but in general, no, you can't have a portion of this building. So if you can't have a portion of a building, a portion of a story, this would be a discrete domain. And to explain it, you just say you cannot have part of a story. Ta-da! All right, for your lesson, this is lesson 4.2. You have already done on your own numbers 1 through 3. We're on page 150. No, you're on page 160 for your homework. Page 160. You're doing the practice and problem solving numbers 3 through 19. All. And then when you submit these, I'd like you to submit them online if you can. That way I can stay up with my grading. The way you do that is you take a picture of each page that you do your work on, piece of paper, and you attach those as files into this assignment in Google Classroom. If you have problems with that, let me know. If you don't have access to Google Classroom very easily to submit things, you can keep them all in a folder and turn them in the lobby every Tuesday. Good luck. Holler at me if you have questions.